Alright, so let's say you're given this function here, and the question wants you to find the derivative. To do this, we need to know the quotient rule. Suppose f of x is given in this form, where f of x is our function, u of x and v of x are two functions that both depend on x. Then f prime of x will be given by this expression, where f prime of x just means the derivative of f with respect to x, and then u prime of x and v prime of x can also be written in this form. So we can apply this to our situation. We have our function, and we know that it should follow this form to use the quotient rules. We can identify u of x and v of x in our equation. So u of x is going to be the numerator, 2x plus 3, and then v of x is going to be the denominator, which is x minus 1. If we analyze the quotient rule equation, we also need u prime of x and v prime of x. We can start off by looking at u prime of x, plug in u, which we just found. We can distribute the ddx to each term. The term on the right is going to be equal to 0 because the derivative of a constant 0. The derivative on the left, we can use the power rule given by this equation here. So for x, it's the same as x to the 1. A is going to be equal to 1 in this situation, and so we can apply this to the power rule equation. If we do that, we get 2 for the answer, so u prime of x is going to be equal to 2. And we can do the same thing for v prime of x, take the derivative with respect to x of v, and so we can plug v in and distribute ddx to each term, and then apply the same steps and get this for the answer. And so we can plug all these values in that we found into the quotient rule equation. To do that, we get this expression here. From here, we can do some simple simplifications. We can start with the top right term here, 2x plus 3 times 1 is just 2x plus 3. And then the top left term, we can distribute the 2 into the bracket. And then for the x minus 1 squared term, we could break it up into its two brackets and then distribute and simplify. Note that there is a small error here. It should not be plus 2, it should be plus 1. Sorry about that, guys. But the process is the same, so we plug these values in to our expression, and then we can simplify it down and get this for the final answer. This is the final answer for f prime of x, which is the derivative of the function given here, f of x. Note, this can also be found using the product rule, which is sometimes simpler. So we can write the function in this form here, where we transform the denominator to an expression that's equivalent in the numerator. X minus 1 to the negative 1 is the same as 1 over x minus 1. Using this notation, we can apply our product rule equation instead. And if we use this equation, we'll find that we get the same result at the end.